Alright guys, today this video is about writing formulas and naming ionic compounds. This is the first lesson. It's actually the first two for you. So this is just with group 1, group 2, aluminum, silver, cadmium, and zinc compounds. It doesn't have any of the other transition metals in it. Alright, before we get started we need to review the periodic table and the charges for everything. And so one thing that you need to remember is that group 1 is usually going to be plus 1. So group 1 is usually going to be plus 1. Group 2 is usually going to be plus 2. Let me make that bigger. Plus 2. Aluminum is usually going to be plus 3. Carbon, silicone, so the separation line is right here. So carbon and silicone is usually plus or minus 4. Nitrogen, phosphorus, and arsenic is oftentimes -3. Oxygen, sulfur, selenium is usually -2. And the halogens are usually -1. Now, all of the ones in the middle, these transition metals, let's see, it'll work. These guys, their charges usually vary, even these right here. And so we can't use those yet. There's a different way of figuring out their charge. But we do know what silver, cadmium, and zinc are going to be. So silver is always going to be plus 1. Zinc is always going to be plus 2, and cadmium is always going to be plus 2. So you should really have your periodic table out, the one that you can draw on, and mark those on there so that you don't forget and you can learn them while you work problems. Alright, and then there's one more, hydrogen. Hydrogen can really be either plus 1 or minus 1 because it's a nonmetal, so it's pretty electronegative, so it can take electrons if it's bonded with the right thing. Alright, so whenever we say what's the charge of sodium, it's going to be plus 1. Calcium is going to be plus 2. I'm not going to ask, or not going to come back to this table, so I'm expecting you to have this written down somewhere so that you can go back to it when you need to. So nitrogen is -3, sulfur is -2. Alright? Okay. Okay, so before we can actually name compounds, it's called nomenclature. All right, and we're just talking about writing formulas and naming compounds. And that's described as chemical nomenclature. Nomenclature. Okay, and we're just starting out with simple ionic compounds. So whenever you see an ionic compound, it has the word ion in it, and that's because it's a combination of a cation and an anion. So there's an attraction between the positive and the negative. And so the cation, right, comes first. So we always have a cation, and then we have an anion. Just for your own knowledge, this is usually the metal, not always, but usually, and this is usually the nonmetal. All right, and for the anions, what we do is we change. So the nonmetals are going to have a negative charge. They're the anion, and it's going to be, we have to change the ending. To IDE, so to ide. All right, now I'm going to move that up a little bit. So if we have, let's say, chlorine, right? This is chlorine. Then this, with its charge on it, since it's the anion, would change to chloride. Okay, and this is oxygen. So with the negative charge, it becomes oxide. And some of them, it can get kind of rough trying to figure out how the ending goes, but you get the hang of it after a while. All right, nitrogen is N, and so the anion becomes nitride, right? And then we've got hydrogen, so H minus would be hydride. So that's how you can know if hydrogen, because hydrogen can be plus or minus one. So if it ends with "ide," then it's the negative one because that's the anion. All right, and then so for magnesium, or Mg2 plus, because that's the cation, the name doesn't change. This is magnesium, and this is just the magnesium. I'm sorry, you can't see that. This is magnesium, and this is just the magnesium ion. So the name is still just magnesium for that. All right, so let's look at some of this. Okay, so we're going to name ionic compounds, and the first thing you do is you name the cation, and then you have to name the anion. So the cation here is Na, so that's sodium. And then this, since it's the anion, it's the second part, right? It goes cation, then anion. You're just going to say nitride because it was nitrogen, but we changed the ending to "ide." All right, and then number 2, that's going to be sodium again. And then the ending, chlorine, becomes chloride. All right. And so this one, the first one, the cation, is lithium. And then the second one is oxide. And then here for this one, that's going to be calcium. And since this comes second, that means that it's the negative version of hydrogen, and so it's hydride. All right, and then the very last one is aluminum oxide. Now, somewhere throughout this, if you've never been taught this before, you're probably thinking to yourself, well, where did the little numbers come from? Why aren't there charges? You said it was an anion, and anions have to be negative. So we're going to talk about that in just a minute. But when you name these compounds, you do not have to look at these subscripts here. All right? It's just going to be aluminum oxide because it's aluminum and oxygen. All right, so now we're going to write the formulas for those compounds that we just wrote the names of. So you can see where the subscripts are the little numbers. So you can see where they came from. All right. So the first thing you have to do to write the formula is write down the ions. So sodium's ion, sodium is +1, and nitride is N3 negative. Now, whenever you have a compound, compounds do not carry charges. Ions carry charges. These are compounds. Their charges cancel out. So if I have 3 negatives right here, I have to make this be 3 positives. All right, and the only way to get this to be 3 positives is to have 3 sodiums. So the formula here is going to be Na3N. All right, because if I have 3 NAs, that means I have 1, 2, 3 NAs, and then I have 1 N3 minus. Then this is 3 plus, and here's 3 negative. And so that cancels out. And that's where those subscripts come from. It's balancing out the charges between the 2 ions. So there's still ions they're just balanced out so the charge doesn't get seen on the compound here. All right, and so this would be our answer for that. Okay, so sodium chloride, we have sodium plus, Cl minus, that's the charge for chloride. And so to balance those charges, we only need one of each, and so it'll be NaCl. All right. So now let's see if I can move it all up. All right, lithium is Li plus, oxide is O2 negative, and so if we want to balance out these charges, you can either think about it and say, okay, this is +1 here, and this is -2, so I need 2 of these to balance out one of those, or you can just take that number and bring it down here, and then take the 1 right here and bring it down here. You're not taking the charges down. That's just an easier way to balance out the charges. Okay, so if you did that, then you would end up with Li2O, which is the same thing you would have gotten, because remember, if you have 2 Li pluses and 1 O2 negative, then the 2 negatives here balance out the 2 positives right here, so they cancel out. All right, next we have calcium hydride. Calcium is 2 plus, and hydride is H -1. And so I can bring this down here, and I end up with CaH2. All right, aluminum sulfide. So aluminum is +3 on the periodic table. Sulfide is S2 negative. And so we're going to do the same thing. This 3 comes down here, the 2 comes down here, and I get Al2S3. All right, and if you want to check that, aluminum 3 plus, if we have 2 of those, then that's 6 plus altogether. And then if we have 3 S2 negatives, then that means I have 6 minus, and so that cancels out. All right, so let's see, I think I have a couple more here. Is it going to move? Yep. All right. Next is calcium selenide. And so calcium is 2 plus, selenide is Se2 negative, and so if we write that compound, because they're both 2's, they cancel out, and so you get CaSe. All right, because we need only one of these for one of those. It's the same charge on both of them, just opposites. And so next is silver, and we said silver always has a +1 charge. Oxygen is O2 negative, and so if we bring that 1 down, bring that 2 down, we get Ag2O. Okay, so those are the simplest compounds. So next we're going to introduce the polyatomic ions. All right, and this was the list that you got in my class, the very first list. All right, and so we have hydroxide, nitrite, nitrate, cyanide, permanganate, yada, 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 all the way through. And so all these are -1 charged, all these are -2, these are -3, and then this one by itself, ammonium, is +1. So this is the only cation. Everything else, these are all anions. All right, and so to make sure that everybody understands, SO4 2- right here is going to be sulfate. And then SO3 2- is sulfite. And then S2- is what we were using before. It's right off the periodic table. This one is sulfide. All right, and so if we were to make a compound with each of these using sodium, all right, then I would have to combine sodium with sulfate, right? And so I would have then Na2SO4, right? Because we would need 2 of these for one of these, okay? Because this is -2 charge. S with 4 oxygens carrying a -2 charge is sulfate. And so sodium and sulfite would give me Na2SO3, and then sodium with sulfide would give me Na2S. And so the name of these would be sodium sulfate, and then sodium sulfite, and sodium sulfide. So you can see how it's really important that your endings end up being correct for what you see. So this one is sulfate, and remember the -2 charge just came down here. And this one is sulfite, again the -2 charge just came down here. And this one is sulfide, and the -2 charge just came down there. All right. So let's do a couple of these. So hopefully you have that list in front of you somewhere so that you can follow along. So we're going to write the formulas for these compounds. So beryllium is in group 2, so it's Be2+, and then nitrite is NO2 1-. And so if we're going to write the formula for this 2 has to come down here, right? And the 1 has to come down here. But we have to think about what we're doing, because if I just write that 2 down there, then I would get BeNO2 2. Well, I don't want 22 oxygens. That doesn't make any sense. I need 2 of all of that. So the way that that is written is Be, and then we use parentheses to say I've got 2 nitrites to balance out the 1 beryllium. And so that's the correct answer. All right, next we have silver carbonate. So silver has a +1 charge, and carbonate is CO3 2-. And so to balance that out, the 2 comes down here, the 1 comes down here. So this time the 2 is going to come down in front of behind the silver. And so we're going to have Ag2 and then CO3. All right. So let's do another one. We've got cadmium chloride. So cadmium off your periodic table is +2, and then chloride, it ends with "ide." It's right off the periodic. It's just chlorine with a negative charge. Okay. So keep in mind which ones are on the periodic table and which ones are on your chart. So this time the 2 comes down here, the 1 comes down here, and it's just like the ones we were doing earlier. So this is going to be cadmium chloride. All right, and so if it ends with "ide," it's probably on the periodic table. Okay, the only exceptions to that are OH, which is hydroxide, and CN. Oh, you can't see it. CN, which is cyanide. Those are the only 2 that end with "ide" that are polyatomic ions. All right, let's do a couple more examples and then we'll be finished. Okay, so this time I've got the compounds and I just want to name them. So just like naming the other ones, you just name the cation and then you name the anion. And so Ca is calcium. And then I have two ClOs. ClO is hypochlorite. All right. And you can see in this next one, this is going to be calcium. Now I have ClO2, and I have 2 of them. So this right here is just chlorite. All right, so don't get confused about the numbers outside of the parentheses. That's just telling you you have 2 of those ions. So you just pay attention to the numbers inside of the parentheses when they're there. Okay? So number 3 is just going to simply be magnesium phosphide. All right. Number 4 is silver. And then PO43 minus is phosphate. Okay? So we're looking at the PO4, and that's just going to be phosphate. Next we'll have lithium, and that SO3 is sulfite. Okay, and then the very last one is sodium permanganate. I don't think I'm going to have enough room. Ganate. That's terrible. I can't leave it like that. I'm sorry. So it's going to be sodium permanganate. All right. I hope this helps. This takes some practice. It takes some working some problems, getting a couple of things wrong, and then all of a sudden it starts to click pretty quickly. But then when you learn something new, you forget the old stuff. So keep trying to work through the old stuff while you're learning new things.